today I want us to discuss about negative and fractional indices, and we are on page 9. And of course, before then, we need to remind ourselves about the laws of indices, and we need to remember, for example, if a is raised to power m times a raised to power n, then according to what you know, this is a raised to power m plus n. Again, if a is raised to power n over m, this is simply the m root of a, everything raised to power n. At the same time, if a is raised to power minus m, this is written as a reciprocal 1 over a raised to power positive m. Now, from this one, we can talk about a raised to power m divided by a raised to power n, which is basically a raised to power m minus n. But most importantly, a raised to power 0 is equals to 1. And I just want to ask somebody to try and prove this, that a raised to power 0 is equals to 1. We will look at it at the end of the chapter. Having said that, I want us to look at example 9, whereby example 9 talks about x raised to power 3, or rather simplified, x raised to power 3 all over x raised to power minus 3. And this one is simply going to talk to follow the law of division. The law of division, which is in turn x raised to power 3 divided by x raised to power minus 3, which is x raised to power 3 minus negative 3, which is basically x raised to power 3 plus 3, which is x raised to power 6. And that is how we get x raised to power 6 at that particular point. Remember, this is example 9. This is example 9 and part A. This is example 9 and part A. What is in example 9 part B? In example 9 part B, we're talking about x raised to power a half times x raised to power 3 over 2. X raised to power a half times x raised to power 3 over 2. This follows law 1, whereby when the base is the same, we add the indices x raised to power a half plus 3 over 2, which is basically x raised to power 2. And that is the end of it. Part C, we are going to have part C, x raised to power minus 3, x raised to power minus 3, and everything raised to power 2 over 3. This one is following a law which we have not highlighted here, but we can also have it here, x raised to power m. The whole of that raised to power n is supposed to be a not x, which is raised to power the product of the two m n. So in this case, you're going to have x raised to power minus 3 times 2 over 3, which is x raised to power minus 2. If you may wish to write that one as a fraction, then you can talk about 1 over x raised to power positive 2. It is the d part that we must take care of. It's the d part that we must take care of. Part D talks of 2x raised to power 1.5 divided by 4x raised to power negative 0.25. And it goes without saying, of course, you can see we have a whole number here. So the whole numbers will divide each other. So you're going to have to, first of all, 2 over 4, which is basically a half, or 0.5. That is as far as the whole number quotient is concerned. What about x now? X raised to power 1.5 divided by x raised to power negative 0.25, which is basically going to use the law of division. X raised to power 1.5 minus 0.25 is the same as x raised to power 1.75. So when you bring them together now, because it was in the same setup, then the final submission becomes 0.5x raised to power 1.75. 0.5x raised to power 1.75. Let us look at part E. Let us look at part E of the same. Part E. Let's look at part E. Let's look at part E of part E of the same. You're going to have the third root of 125x raised to power 6. The third root of 125x raised to power 6. You must realize that the cube root affects all the numbers, or each and every element in the bracket. And you're going to have, and of course you know, the cube root of 125 multiplied by the cube root of x raised to power 6. And we know the cube root of 125 is the same as 125 raised to power 1 over 3 times x raised to power 6 raised to power 1 over 3. Of course, the cube root of 125 is 5, and the cube root of x raised to power 6, we need to get the product of that. We need to get the product of that, and we are going to have 25x squared. How do we get 25 there? If we may want to talk about 125, we can write that one as 5 raised to power 3. When we raise this one to a power 3, when we raise this now to the cube root of, when we raise the cube root of 125 is 5. Yes, 5, not 25. Is actually 5, not 25. Because when you have this, it's the same as 3 times a third, which is 5 raised to power 1, which is basically 5. Yes, there we are. So the final submission is that. What about part F? Part F of the same, 2x squared minus x all over x raised to power 5. If you look at this setup, you can see that we have 2 terms in the numerator and 1 term in the denominator. You must be advised that the denominator affects each and every term up there. So if we can rewrite this one, we may have 2x squared over x raised to power 5 minus x over x raised to power 5. So dealing with each term at a time, this one already gives us 2 raised to power 2 minus 5 minus 2x raised to power minus 3 minus x, 1 minus 5 raised to power minus 4. And moving forward, we can already see that if we want to rewrite this one in a more simplified manner, then we can have 2 over x cubed minus 1 over x raised to power 4. And that is what we can get at the final end. All right?